Hello, my name is Justin and this is my YouTube channel American Pie. Today we're doing Leetcode number 1161, maximum level sum of a binary tree. Given the root of a binary tree, the level of its root is 1, the level of its own children is 2, and so on. Return the smallest level x such that the sum of all values of the nodes at level x is maximal. So if we look at example 1, we can see a binary tree that goes 1, 7, 0, 7, negative 8. Then the output of this is 2. Now the reason the output of this is 2 is based not on the vertical leveling, but the horizontal leveling. 7 plus 0 is the maximum sum of this tree, and that's at index number 2 because it's the second node in the list. So if we scroll down to example number 2, we don't get this fancy diagram, and because of that, it's hard to visualize, so I'm going to skip it. Next, if we look at the constraints of the given problem, we can see that the number of nodes in the tree is range 1 to 10 to the 4, and that the nodes value are between negative 10 to the 5th and positive 10 to the 5th. With all this defined, let's go ahead and get started. So let's start by defining what we need to solve this problem. So we care about each horizontal level. All we got to do is get the sum at each horizontal level, and to do that we probably need to traverse this tree. So I'm thinking the best data structure for this is probably going to be a hash map, an associative map between the level and the sum at the given level. Next, we're going to need to do some sort of graph traversal in order to find what the sum is at each level. The way that I prefer to do graph traversals for binary trees is generally to use a recursive helper function. The reason I like to do this is because it's a lot easier for me to read the code and understand what's going on. So in this helper function I've created, graph traversal, I've passed in two arguments. The root node, which is the current node we're visiting, and int level, which is the current level of the tree we're at. Generally, with recursion, you should define the exit conditions first. So first, I'm going to say if our node is null, we should just exit. Now, we're going to have some logic in the middle, which is going to be responsible for mapping the sum of each level. And then finally, we're going to have our traversal logic, which is going to be at the bottom. So for our traversal logic, we're just going to call our same helper function and pass both the left and right nodes. And just increase the level by 1 for each call. Now, on to the main logic for how we're going to find the sum at each level. Well, earlier I suggested we create a hash map that maps the level to the current sum. So I'm going to do that in the field here. It's going to be two integers with the left, the key being the level, and the sum being the value. So now that we've created a hash map, we can create the logic for the current sum. The current sum should probably either equal 0 if there is no sum at that level, or it should equal whatever is the associative value of the key at that level. So I'm going to use the get or default implementation to do this. Next, I'm worried that since we could have 10 to the 4 possible nodes and each integer value can be up to 10 to the 5, that we may have a circumstance where the current sum could overflow. However, I did some basic math on my calculator and I learned no, that's not the case. So now that we got the current sum, the next thing we're going to need to do is calculate what the new sum is with the value at that level. So it's just going to be at the level, its current sum plus the current root value. Next, since we've completed our graph traversal, we're going to go ahead and call it in max level sum. And then from there, we need to calculate what the actual maximum is. So we're going to need to create a for loop that goes over every entry in the hash map. So jumping ahead a bit, I made my for loop. Now we need to know what the maximum value is at a given index. So I'm going to create two variables. My first variable is going to be called max value, and the second is going to be just the index where the max value is. So we know that all graphs start at the index 1, and for max value, we know that the range is going to be between 10 to the negative 5th and 10 to the 5th. So if we choose integer.min value, well, that's always going to be out of the 10 to the negative 5 range. So it's guaranteed to be smaller than every possible entry. Now, we're going to just calculate whatever the new max value is by checking if the current value is greater than that. And if it is, we're going to set the index to be that as well. So, oh, it looks like I have some errors. So it looks like this should be a capital E in entry, and it looks like my null pointer check here should be like this. Okay, so test cases passed. Let's just go ahead and submit this because I can't think of any new test cases. And it looks like okay, beat 93% at 8 milliseconds. That's pretty good.